Okay, so this time we're going to try to balance an equation that is hard for even chemistry teachers to balance. One of the hardest equations to balance that there is. And that's because it's a multiple step reaction. So these are the initial reactants and these are the final products. If you look at this reaction, we used to use this to start the thermite back in the day. See the little singe marks? I put it a little too close to the demo, I guess. This reactant involves some polyatomic ions. Can you observe any polyatomic ions in this equation? I think one of them is really obvious. Why is it so obvious? Why is it obvious? Because it's in parentheses. If you ever see a chemical that's in parentheses, that is a polyatomic ion. Well, which one is it? That is hydroxide, OH minus. That is the functional group for alcohols. It's also in many, many bases. A lot of bases are hydroxides of an alkali metal. Can you see another polyatomic ion? Well, there's one, MnO4. It's not given away, there's only one of them. That is called permanganate. This is called potassium permanganate. Are there any other polyatomic ions present? Oh, I see one more. This one, CO3, carbonate, CO3 2 minus carbonate. So there's 3 polyatomic ions present. Well, that should make this easy, right? Because usually if there's polyatomic ions present, well then you can sort of balance them on the 2 sides and it really helps you, it saves a lot of time. But where did they go? Where's the permanganate over here? Where's the hydroxide over here? Where is the carbonate on this side? So the polyatomic ions are not present on both sides. You could sort of say these ones are destroyed by the reaction. And if that's the case, well then you can't use them to help you balance. Well, so much for that. Actually, one of them is not actually destroyed, if you really think about it. But, you know, I'm just going to ignore that for now. Okay. So I balanced this years ago, but not for a while. So I'm trying to put out of my mind anything I know about it. I'm just going to try to use the techniques that I've shown you to try to balance this equation. And what's the first technique? Start with something that is once on each side. So let's see, potassium. Well, there's a potassium right there. Potassium is right here, and it's right there. That's once on each side, that's okay. What about Mn? What is Mn? Manganese. Manganese is once right there, and it's also once right there. It's not anywhere else on this side. So those are good ones to start with. Are they in different amounts? Yes. Okay, well what else is present once on each side? Let's see, maybe carbon is. Carbon right there. And oh, there's a carbon, okay. And is there any more carbon? Yes. Oh, so carbon is actually split up. So that's not a good one to start with. We'll deal with the carbon after we deal with those other ones. Is anything else present once on each side? Well, what about the hydrogen? Okay, so hydrogen is there and there. But that's all in one chemical, so that's okay. And where is it over here? It's only there. So actually hydrogen is not a bad one to start with. Okay, we could actually do hydrogen also. So that's a good one to start with. What about the oxygen? Okay, here's oxygen. There's oxygen. Oh, there's oxygen. And oh, there's oxygen. There's oxygen. There's oxygen. And there's oxygen. Well, forget about oxygen. Oxygen is the last thing we want to start with. It is in every single one of these compounds. That means it would be incredibly hard to balance the oxygen at the beginning. We want to do the oxygen last. And then just before that, we probably want to do the carbon. And the ones we want to do first, potassium, manganese, or maybe even hydrogen. Because hydrogen is once on each side in different amounts, why don't we start with the hydrogen this time? Actually, why not? Let's just do it. So hydrogen is present on this side. How many hydrogen are located here? That's a polyatomic ion, meaning it's multiplied by 3, and then there's 5 more. So with a coefficient of 1, that means 8 hydrogen on this side. And then how many hydrogen are located here? Obviously 2. So how can I make this 8? Okay, well, I need to multiply that. I need to multiply this by a coefficient of 4 and then I've got 8 hydrogen on this side. So hydrogen, 8 and 8, boom, done. Now let's deal with the potassium. Potassium, there's 1 on this side, and there's 2 on this side. Okay, so how can I make this one 2? Well, just double it. Just double it right there. Boom. 2 potassium on each side. And then, oh, that also gives me 2 manganese, right? And I've got 2 manganese on this side, so that's good. 2 and 2. So look, we've already got 3 of the 5 balanced. So this should be really, really easy, right? How many carbon do I have here? Okay, we did the 3 that are easy. So now the carbon would be the next one, and the last one would be the oxygen. So we've got 3 carbon. And how many carbon over here? Well, here's 1 carbon. Oh, here's another carbon. 2. 3 and 2. 3 carbons on this side, 2 carbons on this side. What does that remind you of? 3 and 2, odd, even. So what do we do when we have odd, even? We make the odd side even. Even if it's more, we make the odd side even. So I'm going to double this now, getting a lot of 2s and 4s here. And now I've got 6 carbon. That changes this to a 6. And now I can make this match. How can I make this into 6 carbon? Well, the easy way would be to not mess with the potassium or the manganese, not mess with either one of those, but only mess with this one. If this is only 1 carbon, okay, well then I could make this the rest of them. I could make this 5 of them. Boom. 5. Oh, sorry. 5 plus 1 is 6, so then they're balanced. So that's pretty good. So we've got 6 carbon, 5 carbon and 1 carbon, 6 carbon. We've got potassium, manganese, carbon, hydrogen, boom, 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 boom. One more thing, oxygen. So let's see. If the oxygen just falls into place, brrr, then that's great. That is just great. So let's see, how many oxygen do we have right here? Okay, well let's see, I've got to add these up now. That gives me 8 oxygen right there. And then how many are here? Well, that's 3 times 2, 6, that's 14 total. 14 total oxygen atoms on this side. Okay, so oxygen is all over the place here. So let me just be careful. 3 there, 3 there, 10 there, and 4. Okay, so, well that's 14. Oh, plus 6, that's 20. So yeah, everything balances but the oxygen, which is a big problem. You can't have even the slightest thing out of balance. So how are we going to fix that? Well, let's see. Got 20 oxygen on this side, 14 on this side. Something is not working here. Something is not working. Sometimes, if you're in a situation like this, it might help to sort of double all the coefficients and then adjust from there. So let's see if we can sort of do that. Let's see if we sort of double everything and just see where that leaves us. And then we might be able to adjust from there. So that would be a 4. That would be a 4. What would this one be? 2. This would be a 2. This would be a 10. This is crazy. This is crazy. And 8. Okay, so then let's just see what our numbers are if I do this. Most of them should just be doubled. Like that should be 4 potassium, 4 potassium, 4 manganese, 4 manganese. Let's deal with the hydrogen. So that's 8 hydrogen in here times 4, 32 hydrogen, right? 8, 32 hydrogen. Okay, and then how would I get 32 hydrogen over here? What coefficient would I need? I would need a coefficient of 16. That would give me 32 hydrogen on both sides. Okay. And then how many carbon would this be? 4 times 3. 4 times 3, that is 12 carbon. And how many carbon do I have over here? I've got 10 carbon, right? And 2 carbon. Oh, good. Carbon is good. That's pretty cool, pretty cool. All right, so let's see. What else do we have to add up? Well, the oxygen. of course. Everything matches, except for the oxygen. So let's see. Oxygen, we've got 16 right there. And we've got, that's a 3, right? So then 12. Okay, 16, 28 oxygen. Let's see what we've got over here for oxygen. We've got 6. We've got 10. Okay. 22. And then we've got 16 more. So that's 26 plus 12. That's 38. Oops. So the oxygen is a little bit off. All right, so let's see here. What's a good thing to do? Well, we don't want to mess with the potassium and the manganese because those seem to be balanced. We want to really mess with the, what do we want to mess with? I guess the carbon would be the next one. So we don't want to mess with this coefficient because if we did, it would throw off the hydrogen. So we've got 12 carbons. Let's see if there's another way to split the carbons. The only problem is if you do anything over here, it would mess with the potassium and the manganese. So let's see, if we have 12 carbons on this side and then 12 carbons on that side, well, it's either 10 and 2, or we could split it any other combination that adds up to 12, like 6 and 6. You could split it 6 and 6, but this would cause a lot of chaos. But let's try it. Let's try splitting it in half. Let's try splitting the carbon in half. The reason I'm doing this is because after the potassium and the manganese, the carbon is the least split one on here. Oxygen is the last one. Now this is going to throw everything into craziness. So let's just deal with it. Maybe this will work. You got to try to deal with the carbon because I can tell that the carbon is split twice. That's the one we're going to have to deal with. Okay. So, and that would not change the hydrogen. That would be 32. And that would be 32 over there still. And it would not change the carbon. That would be 12 there. So now, and we still have 12 over here. That's what we're trying to start with. So now we're going from the hydrogen directly to the carbon and dealing with the pieces as they fall. So this gives me 12 potassium on this side. So how could I make this? How could I make this into 12 potassium? But I have to put a 12. I'd have to put a 12 right here, wouldn't I? Put a 12 right here. And then that's 12 manganese. Okay. So then, if we want to have 12 manganese, well then this better be a 6 right there. So we'd have 12 potassium, 12 manganese, and 12 manganese. Lots of 12s here. And then maybe the oxygen is going to cooperate. Please cooperate. So, how many oxygen do we have over here? It's 48. Can we write it down? And then how many oxygen are here? That's 3 times 4. That's 12. That's 60. Interesting. These look like kind of good numbers. I don't know. They look good. 60 oxygen over here. Maybe this side will be 60? Let's see. 18 oxygen right there. 18 oxygen right there. Okay, we got 12 oxygen right there. And we've got 16 oxygen right there. So let's see. 18 plus 18 equals plus 12 equals plus 16 equals 64. So no, it does not balance the oxygen. Although it's pretty close, but that's not good enough. That's breaking the law. We must obey the law. Oh man, this is a hard one, right? So again, I'm going to try the same strategy again, keeping the carbon and hydrogen matched up, right? Because, I don't know. And then just trying to split the difference another way. So instead of splitting it 6 and 6, I could try splitting it 7 and 5 or 5 and 7. Let's try the 7 and 5. 7 and 5. And if that doesn't work, I'll try the 5 and 7. Oh man. And of course that's going to change everything. That gives me 14 potassium. Well then of course, if you have 14 potassium there, then this coefficient has to be the full 14. And then that's 14 manganese, right? So then what does this have to be to get 7? So then we get 14 potassium, 14 manganese, and we got 14 manganese. Okay, this is looking good. So now we got everything again, except for the oxygen, and maybe the oxygen is going to just fall into place. Maybe this time, oxygen is going to fall into place. Okay, so let me just do this very carefully because I feel like I'm losing my mind. 14 times 4, 56, plus, how many oxygen are here? This is 3 times 4, that's 12. So 12 equals, what? No, I did a typo. Times 4 equals, plus 12 equals, okay, 68. Well, you know what? Whatever, 68 oxygen on that side. That's a lot of oxygen. How many oxygen are on this side? Okay, so 7 times 3 is 21. 7 times 3 is 21. 5 times 2 is 10. And 16 more. Okay, well, let's see. 21 plus 21 plus 10 plus 16 gives, oh my gosh! Woo! 68! So, woohoo! Oh yes! Wait, let me double check this. Let me double check this. Is this right? Okay, so just to be clear, this wasn't easy to balance. 14 potassium. 14 potassium. Boom. 14 manganese. 14 manganese. Boom. Okay, well, let's see. We just did the oxygen. Let's do the carbon. 12 carbon and 5 and 7 is 12 carbon. And hydrogen. Okay, this is 8 times 4, 32. And 16 times 2 is 32. Oh my gosh, oh my gosh. Wow, balanced it. And you know what, if that hadn't worked, I was thinking about, like, if that didn't work, I was thinking about splitting it the other way, like a 5 there and a 7 there. So it could have gone either way if I had started the other way. And I was thinking about then, like a 4 and 8. Because eventually, the carbon was the key to solving this, because the carbon is only split up one time. And so after you deal with the easy ones, well then carbon has to be dealt with next. Deal with the oxygen last. Amazingly, that worked out. It probably could have taken me a few more tries. Okay, amazingly. So this is the balanced chemical equation, and I think I have it here somewhere. I didn't look at it beforehand. Obviously, you can sort of tell. And does this match? Yeah. Yes. Okay. I did not look at this, believe me. If I had looked at that, it would have gone a lot faster. And I think what I sometimes do is I give students a hint, because that's such a hard one to balance. I sometimes give them this one, I think. I give them one of the coefficients. But I did not look at this beforehand. I haven't balanced this one for a while, for years. So that worked out. It's just not easy. That's a ridiculous equation. That's about as hard as an equation can possibly be to balance. What I forgot to mention at the beginning is that potassium permanganate is a beautiful black, shiny crystal substance, kind of sparkly, and it's very easy to get reacting. It's very reactive. And if you react it with glycerin, which is like a goopy liquid, an organic liquid, it'll give off a lot of energy. And that's why we use this to start the thermite reaction. But then when our potassium permanganate started getting lower quality from the chemical supply companies, we had to stop doing it this way because it wasn't reliable. It became a gray powder. It wasn't so sparkly, very suspicious. Didn't react as well. Okay? By the way, glycerin on its own is just a goopy organic sort of syrupy substance, but you don't want to mix it with nitric acid. No, no, no. That makes nitroglycerin. Nitroglycerin was banned in the USA for about a century because it's an explosive liquid. You don't want to have nitroglycerin lying around. Just ask Alfred Nobel. We'll talk about that, or his brother. We'll talk about that a little bit later. But amazingly, this worked out. And I did not cheat. Don't worry. If I had cheated, I would have made myself look way smarter than that. So this is a ridiculously hard equation to balance. What reaction type is it? Well, it's a lot of reaction types. It's decomposition, it's combustion. So this is many steps. That's why this is so hard. Each one of them would not have been so hard to balance. But putting it from the initial reactants to the final products is what makes it ridiculous to balance.